Oh yeah, hi. Hi, yeah. Oddly silence, I'm sorry, OBS already disconnecting. Right. That was festive. Always a nice way to start the stream. Yes, oddly silent because I forgot to switch the stream to the intro thing. Anyway, everyone, hi there. How you doing? I I'm close to being done. This hole right here is the only thing left for the video. This is the chapter about the CPU. Yeah. Everything on the left I have finished. And everything on the right is what's left. I've been at it for 10 hours today, I think. I think so. I think I've been at this for 10 hours if I'm not mistaken. Yeah, it's been a bit, certainly. Anyway, today we'll be working. I'm sorry, I'm a bit tired. I am a tad bit tired, so I do apologize about that. But yes, today we will be working on the video. And this, oh shucks, I deleted one of the, there we go, this is what I meant to do. Damn it, damn it, damn it, that's not what I meant at all. Alright, so MP5 is the not needed one. Perfect. Now, where am I in the video? And I forgot. Just take a shower.
Operation we like to do. The second one will select which data storage should we use.
Right here, okay.
Select which data storage should we use. Either a 0, so
Right here. How much of the video left? I've just said it a second ago. This right here, that section. That's what's left. Now in here we want to mirror this combination of the 4 logic gates on the left. This time, yes, the combination of the logic gates. Now let me just. So we will want this buffer to go right here. Then we want a NOT. Then we want yet another. It's not quite a buffer. Oh, it's a 10 buffer. Doesn't matter. Then we'll want it right here, I imagine. I suppose that could maybe work. Right here, we could snake around the NOT, and then right here we'll just add the two together. It's a bit cramped, but I could try to make it do. Now the node setup I have for this is a bit big, but I mean, good luck, Megan. I'm gonna sleep. All right, good night, Italian mapper. I would love to go to sleep myself, if I'm to be completely honest with you. Is the passage of time just a force pushing through the 4th dimension? Force is a bit inaccurate of a word, if I'm not mistaken. That's because if you look up force, no, I need to switch to dark mode. If you look up force, it's equal to mass times acceleration, and like acceleration is the derivative in relation to time. So saying that it's a force that's pushing something through time, it's a bit odd because, well, the definition of the force itself like requires time. It's a bit of a loop-de-loop of a definition. So force is more like, to say that it's movement in relation to time, Yeah, we're not getting into relativity. We're doing computer science today. GLSL and OpenGL is not easy. I do not know why. GLSL was GLSL the shader language? OpenGL, I liked it. It was manageable. This buffer right here, I'm pretty certain this is the one. Yes, it is the one. Good. So out of this buffer, we want it to go right here, where we will have two buffers. One and second, then a NOT gate a bit lower. There we go. Right, you will have a NOT gate. Let me just bring this over and plug all of them in. Buffer. Buffer. Oh, what is wrong with you? This is not what I meant at all. I meant not like the NOT gate. Right, yes. That is the correct one. Good night, Piranha, good night. Now let's rotate this 180. Rotate this 180. Rotate this 90 degrees. Plug this in. Ah, it will be a bit cramped. We should probably move this out of the way as well. Which we could just do. We could just animate it like so. Oh, right, all of those are in place. Yes, they are, yes, they are. That they indeed are. What we could do, however, is we could move this right here. Have the node go in directly. We could do it actually. That seems manageable. And then an OR gate right here. Yes. This is the wrong OR, but that's fixable. Sweet. Then all we need is the logic to be plugged in correctly. So into our node we'll get the fucking hell. The topmost memory cell, which is that one, yeah. Topmost memory cell goes into this buffer. Nope, it went to wrong buffer. This buffer. Actually, the NOT gate. Wait, no, it doesn't matter yet. This buffer. Yes. Then the other one goes into the NOT gate right here, which then goes into this buffer. Am I plugging in the right place? I don't know if I am. Hold on. When it's going into a buffer, it is going into the topmost. So yes, I am. Good. Hi, the Dark. Hi, welcome. And then those two buffers both into an OR. Like this. I could have made the gate out of that as well, actually, I guess. It's not too late. Now, whatever, I like it if it's a bit more complicated. Like this, and then all we need is the connections between them, which I'll be first to admit are a lot more difficult. Fudge, fudge, fudge. It's gonna be annoying. That's because the connections are managed right here. So these two wires will be, first we need to select the correct curves. That's the first one. Not the empty, only the curve. That's the second one. Then we need to give them the correct data, which in this case is the memory cell of the operation. Yup. Then what we need is we need the next ones. There's so many of them. I am in fact a bit exhausted with this video already. I don't know if you can hear it in my voice, but I'm a bit tired. Not just the video, but doesn't matter. And then the curve. Go on. I need to click on the correct pixel. There we go. This. Right. The value of it will be the knot at the bottom. There we go. Then what we need is we need both of these to go into the OR. Actually, we need the result to go in there. Like this. Like this. Perfect. Then we just need to connect them all together. It's as simple as it could be. All of it is just as simple as it could be, which means how many more wires? 1, 2, 3. If I'm not mistaken. Which will be... It's all looking very professional, doesn't it? Curve, I'm guessing third one from the end, there we go, which will be the memory cell. Which memory cell, however? It will be the memory cell that's plugged in, that's supposed to be plugged into the buffer. In this case, both of these should be a 6, by the way. And that memory cell is neither one of these. This one. I think that's the correct one, I have no clue. Yeah, the wire is lighting up. That's the correct one. Then the next two will be this one will be, top one will be the mem cell, and the bottom one will be the knot. My computer is struggling with this lot. Hi there, Phoebe. Hi, welcome. So top one will be the memory cell. Buffer, which is this. And then the bottom one will be the other buffer, which is this. Now, the other thing that is going to this buffer will be the input right here. That's because it will be... Yeah, that's because it will be the memory input of whatever we plug in. This is quite chaotic, but I mean, we can manage, I'm certain. And there we go, I think. I think that's just render image, although... No, yeah, render image. It's taking a fair bit of a lot of time, I do have to say. Oh, we don't need to save this render animation. I'm exhausted. I really want to go to bed. But hey, I'm already how many days late on the video? Shit. I pressed the render animation on the wrong thing. Oh no. Wait, no, there's no difference between them. This can actually be not bad. Please tell me there was no difference between them. Oh my goodness, thank goodness. Oh, there's actually no difference in between them. That could have ended poorly. Fortunately, it didn't. There we go.
Storage should we use? Either a 0, so memory, or 1, so the output register. Then the third bit will tell us if we'd like to read it into our registers. If not, that bit will be used to load a byte from memory.
I need to do the same thing and make it, you bloody idiot. Make it, you idiot. This is so annoying. Because I need to set it up again. Again? How? In this case, I imagine just a single buffer. That's it. That's all I'm gonna do. Yeah, just a single... No, this is not too bad. If it's a single buffer, that's not too bad. We just need it to go like this, and then we'll need this one to move along with the curves, because there's no way we're doing it this way. So let's do to 360. That's not too bad of an idea, actually. And then we'll just do a single buffer right there. That will be going from the output of the OR, like this. And that will be the 5th digit. And this will go with the operations memory cell once again. These are quite some geometry notes, I do have to say. Then, right, a bit higher up if you don't mind, because we need the output to actually go in there. Uh-huh. That looks a little crazy. It is, just a little, don't worry. It could be so much worse. It's just a little bit crazy. I could have set it up with like a repeat node, I guess, and then just plug things. That would just be so much cleaner. I mean, yeah, it would have been so much cleaner now I think about it. I could just... It would be a pretty good way to clean it up. Fudge. I'm doing this because if I want, this might be too much. And then index switch first with integers, and then we need to go from the top. You know what, let me just save it as a copy first in case I wreck it. And then let's go from the top down and connect every single value in order. Curve. There is no curve 4, that's curious. Oh no, there is curve 4. That's fun. So I'll have to assign the curves in the correct order as well. Well, that is just neat. 10, curve 11, curve 12, curve 13, 14, 15, 16 and 17. There we go. Then this will go in right here, and this will go in right here into the value. Perfect. And then object info curve goes in. And then the same way object goes into translation. I do have to say, this looks a little crazy. It's quite accurate. Curve 0, curve 1. Then you have a 2, 3, 5. 2, 3, 5. 4, 6. 6, 7. 8, 9, 10, 11. 8, 9, 10, 11, 12, 13, 14. 12, 13, 14, 15. 16, 17, so everything 17, step by step. Then just plug this in right here, and then just cross our fingies that when I delete this, that looks correct. Certainly does look correct. Yay! Awful cable management, rip them all out. So then, there isn't much of a good way to like fix it up though. Then we're working on the last one right here, and we have one additional curve. And now in order to add a new curve, we just well, we just add it in. Curve 18. Whatever, it works, that's the point. Right here. And then we want the data of this curve to come from the OR at the bottom. Like this. Perfect, okay. Then, this is so much more annoying. Because then out of it we'll need to output it, and one side will need to go into this, the other side will need to go into this, which means we'll once again need to create another fork with 2 additional buffers. Let me just, you know what, let's just move these first. Let's just move them. Let's move them like this to get ourselves some more space. And then the first curves, 1, 2, 3, 4. Oh, bad idea. Blender will not like this. Make them smaller. Right. Perfect. Plaguing might get more up-to-date info according to their newest Steam announcement. That's neat. Hi there, Katsi. Hi, welcome. Hi, haven't heard from you in such a long time. Hi, the Theo as well. This look at absolute lad sucking at these notes. I am. Look at this. I am just. I want to be done with this. If I'm to be completely honest, I want to be done. Soon I'll run to the problem of a loop-de-loop, which basically means that all of these, like right here we have a multiplication node, and so this multiplication node is dependent on this register. So we take the value from this register, we put it into this multiplication node, we put it into this buffer node, we put it into this OR node, where it goes into another register, which goes into another buffer, yet another OR, yet another buffer, and then there will be an additional buffer, and then it will go back into the register, with which Blender will not like, and that's because well, Blender won't be able to calculate the value. And as such, it will all just go straight to shit, which means I'll have to disconnect them, I'll have to input these values manually. Which, it's fine. Have you improved at telling accurate information in your videos? I have no idea. If I knew of some inaccurate information in this video, then I wouldn't have put it in. So, I don't know. I can't know. Any inaccurate information I notice, I remove. And ALU or just arithmetic? Well, it's just multiplication and addition. It's meant to be a simple CPU. That's what it's meant to be. I mean, this is kind of an ALU, yeah, kind of, right. But I'm calling it a CPU because in the next video I'll start it by making a program in assembly, and thinking of these in terms of them being registers is really convenient. So it's more, actually, no, it is a bit more of a CPU than ALU, because you can choose where to save the value. I don't think ALUs do that. I can provide assembly code I'm working on. I already wrote the code like a week ago. 2 weeks ago. Jeez, it's been a while. This whole video is a tangent, by the way. Like 2 weeks ago on a live stream, I was working on the code, And then I was like, hey, you know, it would be convenient if I actually explained what registers are and how a CPU works. And then boom, a tangent, and 2 weeks of my life I'll never get back. But I'm fine. I just need a nap. I just need a quick nap, and then everything will be good. Just one quick nap, and then it's gonna be alright. Just a quick nap, just a really quick one, okay? Just like a real quick one.
That bit will be used to load a byte from memory. And then finally the last
bit, which it is. Piss off. There we go. YouTube piss off. There we go.
memory. And then finally the last 5-bit.
Oh, I did in the wrong place.
Then the third bit will tell us if we'd like to read it into our registers. If not,
No,
that
it is
bit
correct.
will be used to load a byte from memory. It will tell us if we'd like to
Like this.
read it into our registers. If not, that bit will be used to load a byte from memory.
To experience you can never experience again, so enjoy. Thank goodness I can never experience it again. Thank goodness.
And then finally the
Can you imagine? Ugh.
last 5 bits, which will work as addresses, either for memory,
Either for memory, which means in this case what we want to do is we want to plug in. We want to just do another curve, I suppose. I think that would work. Which one? No. Kind of. There you are. Duplicate. And then... like this. Now we don't want to duplicate it all the way. We don't need it to be this long. We can delete this. Hi, the comedian. Hi. And then right here we want the memory cell logic, I do believe. And then the additional object will be just the newest curve. Curve 19. And then the last part of the circuit. Isn't it better to do graph stuff for each part /y instead of the whole circuit? What do you mean graph stuff? What do you mean by that? Okay, this goes in at the end. It kind of cuts in there, which just sucks. It looks awful. It looks absolutely bloody awful. This looks a bit better. There we go. 360, 360. Sweet. Geometry knows, I think is the name. No. I couldn't do it for each part separately, because if I was doing it for each part separately, then I couldn't do this. So right here, for example, I can go into the original memory cell, and I can change its value. Hold on, I know it will be a bit hard to see if I have it selected. I can change its value. And it's a bit hard to see, but the entire circuit actually changes. Like right here, for example, at the bottom, that's this memory cell. I can change it to be like 255, and all of these will light up. Which is not something I could do if I did every single part separately. Why didn't you animate in Scratch? Because Blender looks way nicer. There.
Either for memory or our registers.
And then OR registers. That is the last part of the circuit. This is the loop-de-loop I mentioned before. That will not work in geometry node, so we're gonna have to cheese it and do it manually. Which, well, worse things have happened in the past. I'm actually curious, if I plug in a buffer into the logic, yeah, exactly, it all breaks. I was wondering, because the logic technically isn't affecting anything, I was wondering if Blender could detect that, but yeah, makes sense because it's a math node. MS Paint. We need 3 of them, if I am not mistaken. There we go. It will be a bit different from my CPU sim setup, but only a bit, and so no one should care. Logisim or Logisim Evolve? Just Logisim. This, there we go. Then we just need to add in the gates. So they will be memory cell. What memory cell? This file is such a mess. Memory cell 2. And then there is gonna be, no wait, not memory cells, buffer. There'll be 2 buffers and a single knot. What knot? Not a 1. Wait, capital not 1? Capital not 1, okay. So then this buffer goes into both of these buffers. I think in the middle. I am honestly losing it. I think in the middle. And then 0 and 1. Wait, no. 0, 0? I will see. Then all we need to do is just select the appropriate empties, which will be in this case. Buffer, buffer. Oh, that's a knot. Knot goes right here, and buffer. And then both of these rotate to the right. Sweet. This one top down, that's correct, although it is backwards. And then I'm fine. I'm doing so well. All we need to do is just connect them. That should be the last step. So that will be 1, 2, 3, 4, 5, 6. That will be 6 curves, if I am not mistaken. And those curves will be I'm losing my mind with these notes. Well, I'm losing my mind regardless, but with these notes especially. There. We'll have these 2. Oh, I should do it right away so I won't forget. So we have curve 20 and curve 21, like so. Now for their values, they will both be connected to the same exact buffer, which is this buffer. There we go. This buffer, which, oh shucks, I didn't connect the buffer to the... Oh no, I did connect it in the logic, I just didn't connect it. Jeez. You know, make it the middle of the night here in Asia. It's middle of the night here in Europe as well. Is this buffer a register or the buffer slash no operation gate? It's a buffer that's enabled. It's not an actual component that exists in real life, if I'm not mistaken. This is actually the only one that doesn't exist. It's meant to be like a shortcut of a buffer that turns on or off depending on a single selected bit of the third input. Or the second input, I guess. It's buffer. And then the NOT gate, into which we'll want the curve. This one. There we go. Like this, like this, like this. This has to go into... This also has to split, because one half has to go into a NOT gate, the other one has to go into the... I'm fine, I'm fine. It's okay, it's alright. This is just how we'll do it, because I can't think of a better solution. And then the top will go in a much of a similar way. The only difference is we can delete the entire beginning to avoid clipping. And then alright, so curve 22 and 23 will both be just connected to the logic of the operation thing. What's next video gonna be? The thing that I'm working on right now. CPUs, logic gates, stuff. And then curve 22, that's 23, 22, 23, then 1 and 2. Perfect. 1, 2, 3. We're missing 3 curves. Perfect. Which is this right here? 90 degrees, like this, and then 1, 2, 3. Those curves will be curve 24, curve 25, and curve 26. Now, for those, what we'll want is this one to obviously be the NOT gate. So we want the NOT buffer buffer. Buffer, buffer. And then into those buffers we'll have the NOT gate. Oh, which one of y'all is the top one? Okay, the bottom one. So into this we want directly, and into this we want the NOT gate. Like so. And I do believe that, in fact, should be the completed circuit. I think, I hope that should be it. It looks similar-ish, I would say. Oh, in this case, I was using an addition. I could have just... Well, actually, this seems more... Oh, yeah, because there are no OR... Yeah, okay, there are no OR gates there. That makes sense. The complicated... It is, hopefully. I really hope it is. Because, as you can see, it is a lot. And geometry nodes for it ain't pretty.
For memory or our registers. So all zeros selected. So all zeros.
Okay, shut up, make it. The OBS is also lagging significantly, and I think I have a suspicion that the reason is that it's using CPU graphics for some reason, but I can't, like, I have it set to CUDA in... Oh yeah, I have an OpenCL, but I can have it set to CUDA, which, correct me if I'm wrong, I'm pretty certain that's something that only NVIDIA can do.
So all zeros, select the first register, and so all
right here, this is where I'll be doing the zeros, ones, and so on and so forth, but it will be kind of hard to see. All zeros, and this is where, like, the beauty of the come to place. That's because we will have fudge sticks, all zeros on this one, which will be this right here. This will be just a 0. This is what all zeros look like. And this time let's render it as an image. Bye, Buchanan, bye. See ya. No idea why I watch these, but I do, and they're fun. Well, it could be a reason. I'm glad you think they're fun. CPU 362. It is a lot of wires. An awful lot.
Registers. So all zeros.
Right here. Let's transition a bit later. There we go.
All zeros, select the first register, and at least one selects the second.
Oh, not literally all zeros. Hold on. We need all zeros except... Fudge! We need all zeros except... Right here, we want a 1. First... No, wait, we don't care about the operation. Second one... We don't care about the second one there. Third one... Yes. Technically, I cheese here a bit because it's not that... It's every even number selects the top one, every odd number selects the bottom one. Yes. But who cares, counterpoint? It achieves the same goal. Okay, make it. How in the world does the buffer walk? Hold on. I'm calling it a buffer. It's not a pod that actually exists. It's a number ANDed together, which then gets expanded into 8 bits, and that put into an AND. So it's... Yeah, hold on. So it's like... Is there not... Hold on, because it gets ANDed with a single digit. So it's... Conversion to 8-bit. Well, it's from 8-bit to 8-bit. It's from 8-bit to 1-bit to 8-bit, yes. The buffer Zerk and it buffers the Zerk. I wish sometimes something comes up where I can legit help. Like something that I know. This is a bit of dumb effort work, to be honest. There isn't much intellectual work here, it's just something I need to get through.
All zeros, select the first register, and at least one.
One selects the other, but in order to showcase it better, what I should do... I can select it manually, actually, in fact. All zeros select the first register, and then the first register lights up. Is this the correct one, though? Because right here we... Yes, this is good. And then switch them around. And have this be a 1. Like this. Now we're in the image and then the bottom one will light up. Wait, does the top one light up here? Yes, it does. Yes, it does in fact. Good. The only problem is that it's saving nothing. Well, I mean... Actually, this could be a nice opportunity to just... clear them. So this will be a 0, because what we are actually doing is we are writing 0, in fact. Passing 0 at the output with buffer. Oh, it is. Right. I didn't connect it. 26. No, yeah, it is passing 0 because it should be passing 0. It's doing its job. That's correct. So then 0. There we go. Right here. I'm killing 2 birds with one really aggressive swing. And then flip them around. I keep doing this incorrectly, keep having to reset. Yeah, this was supposed to be a 0 when I did that shit. 6, 0, 0. There. That's how it should go. Yeah, right here we are writing zeros. And we get zeros. Perfect. That is what should happen. Then we can actually drag these out because that's mostly what we'll be dealing with from now on. Then we'll have a 1, which means this one is no longer this one is, and it's set to 0, which means we render like so. 2 bits, 1 boulder, exactly, a boulder from my boulder folder. I used to have a boulder folder, those were the days.
So all zeros, select the first register, and at least one. At least one selects the second. Now if we have a read from memory, now we have a read...
Right here I could just pause for a second and like... I probably shouldn't, fuck. I should probably pause here for a second and just go over what each bit effectively means. Let me think. I need to take a look at Okay, so like a brief introduction, a brief, not intrusion, well, whatever. Quick note. Basically, in this register right here, we hold an 8-digit number, where the first digit switches between these two options. Well, let's go options. So either multiplication or addition. Which one is the... We're noting the... So 0 is the multiplication, 1 is addition. Second bit switches between these two, so either output register or the memory, and the third bit, which is between just the saving on off, so we read the number into our data registers, or we don't. Then the last 5 digits are used. No, it's the reading into, or the address in the memory reading from being on our previous configuration. I know it's clear, but the geometry nodes I'm dealing with here, I'm trying my best. There we go. Now, let's record this.
And at least one selects the second.
And okay, a quick note right here, because I just realized how incredibly unclear all this is. Basically, in this register right here, we hold an 8-bit digit binary number, where the first digit switches between these two options, so it's either multiplication or addition. The second bit switches between these two, so it's either output register or the memory. And the third bit switches the saving on or off, so we either read the number into our data registers or we don't read it, we don't save it into the data registers, which are these ones. And then the last 5 digits are used to either denote the register we're reading into, so the first one or the second one, or the address in memory we're reading from, depending on our previous configuration. I know it's not that clear, but these are the geometry nodes I'm dealing with here, okay? So I'm trying my best. Then this should be a good enough of a... This is all actually a very devious plot in order for me to just conserve my music, because I was just running out of music. So now I can just extend this and get more music. Editing is a plot made up by big editing to get me more music. The Muff Pope? What do you mean the Muff Pope?
And okay, a quick note right here, because I just realized how incredibly unclear all this is. Basically,
geometry. I'm fine. So, by the way, how many minutes do we have left to edit? 24, and we're on 70. 7? That's so many.
Binary number, where the first. Basically, in this register right here, we hold an 8-bit digit binary number. Basically, in this register right here, we hold an 8-bit digit binary number, where the
And now what we need is we need the 8 digits. Did I say 8 digits? Bits. Bits and digits. The digits. Need 8 of them and what they mean. So looks actually kind of neat from the bottom. So right there we need text, and we want it to be oh, my computer just got really loud. It's struggling, and I don't blame it. I am really tired and I really want to go to sleep, but at the same time, to be fair, I'm not that close to finishing the video. I still have so much to do. But I don't want to off-put it for yet another day. How many days has it been? It's fine, I can manage. We're so close. We're not actually. 7 minutes is a lot, especially since I don't have any animations. Oh, and the intro, fuck. You know what? I think I don't want to be awake. It's not even that I want to go. I just don't want to be awake. I am done, I suppose, because I can't anymore. I am feeling extremely demotivated, and I'm not gonna finish the video today. I'm gonna finish it tomorrow because this is a lot, and I'm exhausted. Anyway, today that was fun. It wasn't an hour-long stream, very short. I'm sorry, I understand, but you know, I've spent all day working today, and I would really like a bit of a break. And so for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.